All right, everybody. So look, here's the thing. I went ahead and did one more of these proportion questions when it comes to the confidence intervals, so you can have a little bit more confidence when it comes to making confidence intervals, all right? So let's take a look at this question. Very simply, we are saying that we got a sample of 4,217 people, and in that group we got 155 successes, whatever we deem that to be. I'm sure other questions will be a little bit more of a detailed question, but I just wanted to get straight to the important parts. The question here is, what is the 99% confidence interval? Now, when I go about these questions, I like to pick out the important numbers. So the n is going to be an important number because that's the number of trials, otherwise known as the sample size. And I can see from the question it says that we have a sample of 4,217 people. So I'm going to write that down to the side. Then I want to write down my x to the side because I know that that's also an important number. It's the number of successes. I hope I spelled that correctly. As the question says, we got 155 successes. So I like to go through the question and pick apart my important numbers just so that I can be sure of what I am dealing with and I don't have to keep looking through the question. Okay, if you remember, step 1 was to find the sample proportion, otherwise known as the point estimate. In this case, since we're talking about proportions, we are talking about the p-hat. This is a situation for proportions because we got successes and failures. We got 155 successes to be sure out of 4,217 people. So we can do that really quick in the calculator. I didn't film this all the way nice, but it's not that hard plugging this number in. We're going to get that for an answer, 0.036755. I like to give myself some extra decimal point numbers. I get a little bit paranoid. Rounding errors can catch up with you. I don't like to round until the very, very end of the question if the question asks me to do so. So now that I know the p-hat, I can really, really quick get the q-hat for myself. That is always one take away p-hat. So in the calculator, if I just go one take away second answer, since the p-hat is already in there, I get myself a very quick calculation of what the q-hat is. That's a 0.963 244012, but I guess I'll leave it at the 44. That's not too bad. All right, so there, I got my step 1 taken care of, and I even went ahead and got my q-hat to go along with it. Now it's time for step 2. It's to find the error. And as you know, the error has a formula of, we need the z alpha over 2. That's the critical value. We'll talk about that in a moment. And we're going to need the square root of p-hat times q-hat divided by n. Well, we already have a bunch of these numbers, don't we? We've got ourselves the p-hat, the q-hat, and we know by the question that the confidence interval is a 0.99. Well, we know that the alpha then is 1 take away 0.99. Put that in the calculator or do it by memory. That's going to be a 0.01. The alpha over 2 is equal to 0.01 over 2, which is equal to 0.005. You can check these numbers in the calculator. By the way, right now we're doing that little side quest. We need to get this in order to get the critical value. As you can see, I confirmed that my alpha over 2 is a 0.005. That means on the z distribution, that is the standard normal distribution, we have chopped it up such that we've got 99 in the middle, and we've got 0.005 on both ends because of symmetry. And that number that gives us that chop up right there, that is the critical value, the z alpha over 2. Also note that if you add up those decimal points are going to add up to the number 1 because you have to have 100% of the data under the curve, and that's how that works. So if I look this up in the chart or I do it in Excel, there's a nice little Excel formula. We've talked about that. We're going to find that our z-score is going to be, sorry about that. There's the formula for Excel. There is the z-score, 2.575. All right, taking a quick look at the z-score chart, we have to find the 0.995. As you can see, it's sandwiched there between, because of rounding, that actual number is right in between those two values. The z-score is going to be a 2.5, and then that second decimal point is going to be somewhere between 7 and 8. But we have our little chart here on the bottom that kind of shows us that if the confidence level was 0.99, the critical value was 2.575. Alrighty, so we double checked it in the chart. The critical value we need is 2.575. That is the end of our side quest because now we have the last number that we need to calculate this error. Let's go ahead and write that out so that we can set up the formula properly. The error is going to equal to 2.575 times the square root of 0.03675 times, put them in parentheses, 0.963244. Let me close up that square root. That inside number is going to be divided by the sample size, which is 4217. All right, now we can throw everything into the calculator. I'm going to use my method. So we'll start with what's on the top part of the fraction. That number divided by that number equals this, divided by the sample size gives you this. And finally, the square root of that gives you that right there. That's going to get multiplied by the critical value, and we get a final error number right there. That's a 0.00746, and I think I'm going to leave it right there. That's good enough for me for now. All right, and just like that, we have finished off step 2. Finally, we get to figure out what our confidence interval is. That is, we're hoping the reality will be between the p-hat plus or minus the error. We finally got all those numbers. It's just a matter of plugging them in. The p-hat was the 0.0367. So I put 0.0367 on both sides, plus or minus the error that we see right there. That's a 0.00746 on both sides. Let's break out that calculator one more time. Okay, no, without the calculator. I did it on the side. All right, so that calculation is going to come out to those two numbers right there. That's your lower bound. That's your upper bound. I'll give it a little bit of rounding now that we've made it here to the end. We're hoping that the reality is in between 0.029 and 0.044. That is your confidence interval. So we are saying that we are 99% confident that this interval has captured the reality true population proportion. All right, now just as a double check for our numbers and for a little bit of extra practice on how to use that Excel calculator that we built last time, I got it set up right here. As you can see, it has those old numbers. The only numbers I have to change out are the numbers that are in yellow. So I can go ahead and click in there, get rid of that number, get rid of this number, and get rid of that number. Don't worry about those errors. We're going to address that right now. So from the question, we were able to see that our X, our number of successes, was 155. We got a 4217 for the sample size. And as soon as I move away, all those numbers update. But now I still need the confidence interval. That was a 0.99. As you can see, that critical value goes right to the 2.575 number. And we get a p-hat of 0.03675, like we saw. We get our q-hat, which matches what I have over here on the little screenshot. The error number was a 0.00746, and the lower and upper numbers turned out to be 0.029 and 0.044. So as you can see, the calculator in Excel matches what we got on paper. That feels pretty good, and it shows that if we can pick out and understand what's going on, we can pick out the correct numbers, put it into the Excel calculator, and just like that, we get all our important numbers.